better. So we were given the assignment of creating a video identifying a concrete law of physics. So today we're going to talk about projectile motion. Projectile motion is extension to the two dimensions of freefall motion, making it so that a projectile moves along a curved path when thrown near or at the Earth's surface, under the influence of gravity and nothing else. The horizontal and vertical components of an object undergoing projectile motion are independent of each other, creating vertical and horizontal velocity and acceleration. The vertical component of acceleration for all projectile motion is 9.8 meters per second squared, going in the downward direction, while the horizontal component is 0. So in our experiment, we recorded the motion of a tossed ball with a total of 3 throws, all at different distances, short, medium, and long, to compare the effect of gravity and freefall motion on the different calculated velocities. We did this by recording its distance, time, and launch angle. For the first toss, we had the values of 1.28 seconds, around 2.6 meters or 8 feet 5 inches, and a launch angle of 40 degrees. This gives us our known and unknown values. Plugging in our values from the first toss of the experiment, we got a horizontal velocity of 2 meters per second, an initial velocity of 2.61 meters per second, and a vertical velocity of 1.68 meters per second.
This projectile was launched a little bit further than the others to show which values are affected by distance and time in projectile motion. The ball was thrown 3.56 meters, and I predicted that the ball would show a significantly larger velocity because it fell over a larger distance. However, from our calculated value of the initial velocity, we found that it was relatively similar to that of the other times. So our observed initial velocity, based off of a motion graph that we created using video analysis, was 5.06 meters per second, and our calculated initial velocity was 4.98 meters per second.
Test 3 had the shortest distance thrown measured at 1.8796 meters. Using the known values, we calculated our final vertical velocity. The initial velocity of test 3 was 2.90 meters per second. We used this to calculate our vertical velocity at 2.43 meters per second.
These were the final values, or the calculated velocities, of our experiment, along with the created y position and x velocity graphs. But how do they compare to the values found using video analysis? Looking at the created data sets from video analysis, which was done for all 3 tosses, the observed or theoretical values were found. Comparing our calculated values show how close we approached the observed or theoretical values, with error percentages of 4.04, 1.58, and 6.2 respectively. Our calculated values created from the equations of projectile motion did not differ greatly from the values found in video analysis, with percentages closer to 1% being more precise. The greatest difference between the values came from our third toss, while the second toss had the smallest difference. Overall, all values were close to the observed values, with their close proximity going against our original prediction that larger distances would have a much larger velocity. This is due to the single force acting on a projectile, gravity. This leaves us with our final statement. With the definition of projectile motion, we can conclude that the projectile in our experiment followed similar paths due to the single force acting upon it when thrown, the force of gravity. With this, we were able to complete the goal of our experiment, to determine the parameters affecting the motion of the object in freefall after being launched.